Welcome to the digital lecture series. Today we will discuss the clocked RS flip-flop. The basic flip-flop as it stands asynchronous sequential circuit or latch device. But by adding the gates to the input of the basic circuit, the flip-flop can be made a respond to the particular input level during the occurrence of clock pulses. So remember that thing, the basic flip-flop or latch basic flip-flop or latch with clock. Some books say that if there is a clock is a input, this latch is called as a flip-flop. Okay. And clocked flip-flop is that. So clocked RS flip-flop, it is look like is in this figure. This is the basic flip-flop which we already discussed in the last lecture. Now here, the whatever the input, it is ended with clock pulse. This clock pulse. Okay, so reset is equal to here reset whenever the clock is 1, the reset is that and set is will be transferred. But when clock is 0, so the reset is this will become 0 and this will become 0. So the output is remaining stable set. Simple that is. Or in this period, the output is 0 in this particular period. Only during the out clock is 1, at that time this is change. So let's see the behavior of the circuit, how it can be work with the help of truth table of the given circuit diagram. Here, remember that thing, whenever this clock pulse is given, when clock pulse is transits from 0 to 1, at that time only output is changed. So the QT before the clock pulse transition, it is known as a QT, and 1 it will become 0 to 1, the next output. So this is called as a previous output and this is called as the next output or state, next state or previous state. Okay, and it can be bifurcation when the clock pulse is changed from 0 to 1. Remember that thing. So here now that we define qt and qt plus 1. Okay, so we will take each and every condition when the q is equal to, now there is a 3 input q. So this is the previous output. It you can say that it is qt input, external input S and R. Okay, and this is the next output. We understood the things we are talking about this time. The qt plus 1 is generated. So if q is equal to 0, q dash is always 1, complement to each other. So here 0, 1. S is equal to 0 and recess is equal to 1, 0. And clock pulse is changed from 0 to 1. So in this condition. Okay. So what happens? 0, 1, 0, 0, 1, 0. In NOR gate, if any one input is 1, the output is 0. Okay. Don't know about that thing. So 0, 1, the output is 0. And this 0 is here. The 0, 0 output is 1. So we can say the qt plus 1 is 0. The q is equal to 0. Reset is changed to 1. Okay. So 1, 1, this will become changed to 1. 1, 1, 0, 0, 0, 1. Okay. This is not changed. The output of gate number 2 is S equal to 0 and reset is equal to 1. The third combination is 0 1 0. Okay. 0, let me first clear this everything. So Q is equal to 0. Q and Q dash is equal to 1. Set is equal to 1. Reset equal to 0. Clock is given. So next Qt plus 1 is generated. During that things 0 1 of the gate number 1, so output is 0. 1 1 output is 1 of the gate number 2. 0 Q dash and 1 and Q. In a NOR gate, if any one input is 1, the output is 0. This 0 is applied here, so it will become change. 0 0, the output is 1. This 1 is applied here. 1 1, it remains same. So stable output is 1. It is a SAT condition. The first case was reset. Sorry, this one is reset. Okay. Now 0 1 1. Reset will become 1 and all are 0 0. How it can be undeterminate? Let's see. The set will become 1 and reset is also 1, and the previous output was 0. Q is 0. Here it is 0. If any one input is 0, Q dash will change to 1. This one here 1 1. Okay, if any one input here also 1, so this will become 0. 0 1. Any one input is 1, this will become 0. This will become 0. Any one input is 1. So in the both the case, gate number 3 and gate number 4 output is remain same. So Q dash is equal to Q. It is not a valid, so it is called as an indeterminate state when both inputs are 1. Okay. Now the 4 2 raised to 3 8 combinations are possible. So here we discuss 4. Now there is required the remaining 4 condition is that when the Q is equal to 1 here. So Q is equal to 1. Q dash is 0 and both set and reset are 0 0 and clock is applied, so 0 1 0 1 0 0 0 1 in gate number 4. Due to this one the output is 0 0 0, the output is 1, so it's remain same as the previous state. Here in this condition Qt plus 1 equal to Qt. Here also Qt plus 1 is equal to Qt. Now 1 0 1. Okay, reset is changed to 1 and remaining all gates have a same condition. Q is equal to 1. Q dash is 0. Now depends on 1 1, the gate number 1 output is 1. 1 0, the gate number output is 0. If any one input is 0, the output is changed to 1. This one is given to here. 1 1, this will become changed to 0. 0 0, it is already input is 0, so it is stable 1 and this will be not changed. So finally we get reset because the reset input is 1 and set input is 0. It is not depend on the previous condition. Similarly, after the third combination is possible 1 1 0, when Q is equal to 1, Q dash obviously 0. Now it is depends on the output of gate number 1 and 2, and this is given. Set is equal to 1, reset equal to 0. So 0 1 0, 1 1 1, both are 1, the result is 0. 0 0, the result is 1. That means we obtain one SAT condition. Okay. And if all are 1, Q is 1, SAT is 1, and reset is 1. So 1 1, gate number 1 is 1. 1 1, the gate number 2 is 1. Both are 1. The result is 0. 1 0, the result is 0. Again, this will become into 0, but due to this one, the result is 0. Q dash is equal, Q dash is equal to Q. It is not a valid, so it is called as an indeterminate state. So in this way, we understood, we got the all three A condition, and we also defined the difference between the Qt and Qt plus 1. So these 2 is to 3, 8 combinations we discussed. Now, the one other thing, after the truth table, if we have obtained the equation of Qt plus 1, it is known as a characteristic equation. Qt plus 1 is depends on Qt, S and R. So if the equation of Qt plus 1 in term of previous output and external inputs, and it is called as a characteristic equation. Okay. So this is the characteristic equation. We substitute the value of this Qt plus 1 0 0 1 1. Here indeterminate state we consider as a x, these two, and 1 2 and 3 are the set condition of 1 2 and 3. So we obtain that Qt plus 1 equal to S. How it is? This one. And outer side R dash Q. So the characteristic equation is Qt plus 1 is equal to S plus R dash Q, but S and R is not equal to 1. Both are not 1 1. Okay, this is the limitation of SR flip-flop. And the symbolic view of the SR flip-flop is that 2 input reset, set, clock is that, and through output Q and Q dash. This is called as a graphical symbol, which is useful to design a big circuit. We do not require to put the internal combinational diagram logical gates. Only graphical symbol is enough to show the RS flip-flop, clocked RS flip-flop in any sequential circuit design. So characteristic equation of the flip-flop we derive from this map. This equation specified the value of next state, a function of the present state and the input. Okay, and how it is different? Here different is that the clock pulse is ended whenever clock pulse enable. I'm telling you enable. So here the clock pulse is direct. There is a meaning of symbol of this triangular we will discuss later on, but the clock pulse is direct if the bubble is shown here. Okay, if the bubble is given here, the meaning will become change. But here it is enable when the clock pulse is equal to 1. So I hope you understood the things, the behavior of clocked RS flip-flop. Have a good day.